Here I have prepared a supplementary illustration in order to show the use of table of electrical characteristics of conductors, and the topic is still in resistance of transmission lines. So I have like two references for these electrical characteristics, one from Duncan Glover and the other author, and the other one is Granger and Stevenson. Okay, so there are several tables here. This first table is showing the characteristics of copper conductors. As you can see, the data included in this table include size of conductor, they are in circular mills, the number of the strands, the diameter of each strand, and the outside diameter, even the approximate current carrying capacity, the GMR, geometric mean radius, which will be used later on, and also the resistances given in 25 and 50 degrees Celsius respectively, from DC up to 60 Hertz. And there are also here the inductive and shunt capacitive reactances, which again will be used later. Okay, so that's for the copper. And table 8.4, this is for ACSRs. Okay, so there is this code word shown here, and also in circular mills. So since this is ACSR, so this table is showing how many strands and layers of aluminum there is. Okay, and there are also the number of strands of steel, because this is ACSR, remember? Okay, and likewise outside diameter is also given, the GMR, which will be used later, and the current carrying capacity is also there, and also the resistance. All right, again 25, 50, DC to 60. All right, and there are also these reactances. Okay, table 8.3 of the another reference is the same. It has its code word, then showed din yung aluminum area in circular mill. This one is simplified, no? Kasi kikita na sa kanya yung how many strands of aluminum and steel. Like for this one, there are 18 strands and 1 strand of steel. 18 of aluminum, 1 of steel. Oh, sorry. And then layers are also shown here. Outside diameter. Okay. And then liitan ko lang ng konti. Also the resistance. Okay. Resistance at 20 degrees for DC, for AC 60 Hertz, 20 and 50 ohms per miles. Okay, like the other table, there are also this GMR and inductive and capacitive reactances. All right, so another table here. So these are the spacing factors, table A4 and table A5, which will be used maybe some midterms. Okay, so I just have to leave it there. All right, now for ACSR, okay, diba sa table kanina there are like 54.3 or 54.19. Okay, so ito yung ibig sabihin nun, there are 54 strands of aluminum. All right, you can count them. All right, 54, and then 3 layers yung aluminum. Alright? So, parang this is the first layer, and then the second layer, and then the third layer, totaling to 54 strands of aluminum. And on the core, yung steel strands, 19. Okay? So, that's the meaning of that 54-3. Minsan makikita nyo, it will tell you, I'm sorry, it will 54-3 ACSR, or the other way around, 54-19 ACSR. Alright? So, ang ibig sabihin nun, there are 54 strands of aluminum, 3 layers of aluminum. Or, merong 54 aluminum, 19 steel. So, would there be a chance na this is like 19 layers? Or this one ay 3 na steel strands? Let us go back to the table. Okay? So, as you can see here, dito, mas madali dito eh. Okay? So, number of stranding, if you can see it, 7, 1, ano pa? 19. That's all. Diba? Walang, and there is no even a layer that is more than 5. Right? So, madaling ma-identify kung how many strands or layers yung aluminum or steel. Alright? Okay. Let's go back. So, this is the table. These are the tables. Alright? So, that's how we code ACSR. Okay? That's for ACSR only, ha? Kasi that's why it's ACSR. Okay. Sample problem na how to use that. Okay. So, there is this 60 Hertz, 765 kilovolt 3-phase overhead transmission line. So, please take note. According to it, it has 4 ACSR, 113 kc mil, 54 3 conductors. So, ito yung 54 strands of aluminum, 3 layers of aluminum. Alright? So, how many steel strands? Makikita natin later in the table. We just have to locate kung ano to, okay? Now, determine the 60 Hertz resistance of this line in ohms per kilometer per phase at 50 degrees Celsius. Okay? So, we have to go back to the table. Hanapin natin. Let us locate this ACSR 1113 kc mil 54 3. I will make use of this. So, it's not here because this is copper. So, table A4. Alright? So, the circular mil is 1113. Alright? So, it so happened that there is only one 1113 kc mil. Alright? So, there are 54 3. And then, 19 pala yung steel strand. Okay? So, what we will be needing is the resistance data. Okay? Kasi pinapahanap yung resistance. Since ang given is AC, 50 degrees. Alright? 50 degrees daw. Celsius, 60 Hertz. So, what we are actually looking for is this resistance. 0.0969. Okay? So, let's go back. Here's the solution. Okay? So, let R be the 60 Hertz resistance in ohm per kilometer per phase at 50 degrees Celsius. Okay? So, from the table, we got 0.0969 ohm per mile per conductor. It says from the table, it's ohm per mile per conductor. Okay? Alright. Now, since the problem is taking for kilometers, so we just have to convert. Okay? So, this one. Convert. Alright. From miles to kilometers. Alright? Now, I am highlighting this per conductor. Alright? Per conductor. Ang data natin or ang answer natin is in per conductor. Ohm kilometer, yes, per conductor. Okay? sorry. Whoops. Now, my question is, the question pala, the problem is, sabi niya, diba, there is this three-phase transmission line with 4 ACSR conductors per phase. So, as if this is the representation, no? 1, 2, 3, 4 conductors for phase A, line 1. Alright? Line 2, line 3. Okay? Now, ang question kasi sa atin is the resistance of the line in ohm per kilometer per conductor. Okay. This might be a bit confusing, no? However, we have to take note of this, no? In the future calculations, no, later on, we will be considering resistance of the line per unit length. We will always consider that per phase and per unit length. Okay? So since here we are assuming that actually we are not really assuming, no. It says here that in a phase, okay, in a single phase, there are 4 conductors. Okay, ibig sabihin yung 4 na yun, merong, let's say, 3 kilometers. Okay, 3 kilometers yun. Each of these conductors are 4 kilometers. 3 kilometers, sorry. So, per unit length yung analysis natin. So, meaning, what we are looking for here, the resistance that we're looking for here is the per unit length. Per unit length. Meaning to say, yung ohm per kilometer per unit length. Ito yun. Per kilometer. Okay? So, meaning, we have to divide that resistance that we got from the table by 4. Kasi, we're looking for the per unit length. Okay? So, meaning, one conductor, 4 kilometers, kunwari yun. Another conductor, 4 kilometers. So, yung single conductor per unit length kasi yung hinahanap natin. No? Not this. Hindi yung entire, let's say, bundle. Okay? Not this entire bundle of the conductor. Okay? Kasi remember, yung resistance kasi ay per conductor. Okay? So, meaning itong 0.06022 ohm per kilometer is as if it's the whole bundle. That's the resistance. However, we have 4 conductors in that single phase, in that phase 1 or line 1. Right? So, we have to divide it by 4. Okay? So, if for example, in the 3-phase line, there is only 1 ACSR conductor per phase, alright? So, no need to divide by 4. Kasi yun na yun. Yung resistance that we had from the table, yun na yung resistance representing the conductor per unit length. Okay? So, this is the key, no? That's the key word, yung per unit length resistance. It's always like that. Okay? So, that's why our resistance, the AC resistance, particularly 60 Hz resistance in ohm per kilometer per phase is this one. Okay?